Alrighty, so looks like we are going, and here we are to talk about quadratics and all the different types of factoring that students would want to know. My name is Alex Torres, and we've got Pasquale Patrick Spano. We're both internationally recognized SAT tutors with students all around the world, and we welcome any feedback, questions, anything of that kind, whether it be during this actual session or later on with comments on our YouTube, Facebook, or any other type of social media page. How you doing, Patrick?
Doing very well, thank you. I'm excited for this, and if anyone's tuning in or you're going to watch it later, just make sure that you keep an eye on our social networks. We'll be posting a lot. We'll have a lot of free content coming out to help you students and your parents as well. So just make sure that you follow us, you subscribe, any button that you can, just to make sure that you stay in the know. As I said, we'll be pumping out a lot of free content for the SAT, and we just want to help as many students as we can. So get the word out there, and short little segments will be productive. Won't take too much time out of your day, and it could help you boost your SAT score. So stay tuned.
Sounds good. And I am in Fort Lauderdale, Florida. Patrick is in Belgium. So this is truly an international operation, which is the way of the world right now, because if you limit yourself to the tutors available at your school, in your neighborhood, in your area, what you're doing is you're limiting the amount of talent you have access to. But if you say, okay, I'm open to the world, whoever is sort of the best person for the job, then you get to really choose people only based on their ability to help you achieve your goals on the SAT. And when it comes to getting into college and achieving your dreams for the future, there's no playing around as far as I'm concerned. So let's go ahead and get right into it. Here are all the things that you need to know. Everything we're going to talk about right now, you need to be an expert on in order to do well on the SAT. Let's make sure my screen is showing. Okay, so everything we're going to talk about here, you need to be an expert on. So first of all, identifying the type of equation we're dealing with on the math portion of the SAT. A linear equation is going to be marked by having x and y to the first power. Once you've got x to the second power and or y to the first power, so you got x to the second power, this is what we're going to refer to as a quadratic. Now notice that there's no y here. There's a little quick background about it for equations to find the x-intercept of a function, y equals 0, and the converse. But on a lot of the examples we'll be seeing today, there won't be a y because we're assuming y to be 0. And that's just an operation that occurs so frequently in SAT math in general that we almost assume it to be the case. So y is going to be equal to 0 on a lot of these equations, which means that on a lot of them, you won't even see the y there because it's already been made equal to 0. All right, any questions so far?
So what is the symbol f of x or g of x? How does that play in? Is it more for the quadratics?
Well, if I get either of these in the format of y equals whatever it is, once we kind of move everything to one side, then you can replace that with f of x, right? So f of x is just a fancy way of saying y. So for instance, if I said f of 6, what I'm saying is I want the y value of this function when x is 6. So yeah, so essentially the answer to that question is f of x is basically y. So the first type of equation that we're going to get to is just this one right here. It's a quadratic because it's got x squared. And the big thing to say here is that BC factoring is always your first choice. So this is in the format of ax squared plus bx plus c, right? Because it's got the x squared, the x, and then the number. And if that's the case, you know, our a is what's in front of the x squared, our b is what's in front of the x, and our c is the next number off to the end. And we need two numbers that add to b and multiply to c. So the two numbers that add to -2 and multiply to -8 are going to be -4 and +2. So this would factor to x minus 4, x plus 2, nice and easy. And then we have the zero product rule, which says that these two things are being multiplied out to 0 in the way they're being displayed. And the only way that could happen is if one of them is 0. So the next sort of thing that people do habitually is just set each piece equal to 0. And you get your two answers. You get 4 and -2. So just moving a little fast here.
May I point something out, Alex? Just
Go ahead.
so I know for some students, sometimes when we get into factoring, they think a lot of, well, I like to talk about foiling, which would be going from the two binomials that you have into the polynomial, the trinomial on top. So here, in essence, we're doing reverse FOIL. I know a lot of students learn it that way, so it happens a bit quick, but it's like a reverse FOIL, what you said, the BC factoring. And then when you figure out what two numbers multiply to get B, or sorry, add up to B and multiply to get C, that's a little bit of what's going on there. Many students are confused or we're following along a bit slower.
Yeah, so foiling would be to take the blue stuff and multiply it out to look like the green stuff. And factoring would be taking the green stuff and separating it into its elements to get the blue stuff. So the most basic type of factoring is BC, where you're looking for two numbers that add to B and multiply to C. So this is another nice basic example of that. We have number 1 in front of the x squared, so a equals 1. The next number is 2 when it's in the order of x squared and x and followed by the number. And the following number is negative 35. So we need two numbers that add to 2 and multiply to negative 35. Now this is kind of easier because there are not that many numbers that multiply to 35, but on a harder one, what you would want to do is take the number that it multiplies to and divide it by everything that you can divide it by. So 35 times 1 gives you 35. 5 times 7 gives you 35. And so, as you can see, there are not that many factors of a lot of these numbers. So which of these could possibly add to 2? Of course, it would be 7 and negative 5. So x plus 7, x minus 5, and that would be the format that you'd factor it in. If you had it equal to 0, then you could set those equal to 0, and your two answers would be negative 7 and 5. So anything to add there?
So here, yeah, so just so students see again, why is it adding to B, multiplying to C? Because when you would, if you want to check your work, you would FOIL it out. So here, however, here we'd get the negative 35, but then we would get, yeah, positive 2. So that's how you can check your work, right? If a student made a mistake and did x minus 7, x plus 5, you can check your work by FOILing it out, and then you see if which numbers you put, or if the numbers you put are in fact correct. There's a way to check your work. Self-check.
And for people who are watching this who don't know what FOIL is, that's a wonderful Googleable thing there. Just find out what FOIL is. The first times the first, which is this times this, gives us x squared. Outer times outer, this times this, gives us negative 5x. Inner times inner, right here, gives us 7x. And last times last, the two last pieces, 7 and negative 5, gives us negative 35. So first, outer, inner, last, and then when you combine the like terms there, you'd get x squared plus 2x minus 35. So moving right along now, the next thing to kind of keep in mind with quadratics is that if there is a GCF, it trumps everything. You want to always remove GCFs whenever possible. So here you have 3 terms that are all equal to, that all are divisible by 3. So if we divide everything by 3, 0 divided by 3 is still 0, but that gives you x squared plus 9x plus 20. And so now we've got it down to something that's nice and factorable. Two things that add to 9 and multiply to 20 are just going to be 4 and 5. So it factors to x plus 4, x plus 5. And the zero product rule says that you set each of those equal to 0 now, and you get your two answers. So take away 4 from both sides here, negative 4. Take away 5 from both sides here, negative 5. So whenever you have a GCF, that should be the first and foremost thing you look for. Patrick?
2 questions. One, GCF is an acronym for the greatest common factor. And
Yes.
then my other question, some students will ask sometimes, so you divided by the greatest common factor 3. Where did that 3 go?
Well, it literally disappears into thin air because we're dividing by 3 here. 0 divided by 3 is 0, and we're dividing by 3 here. So when you have one side equal to 0, you get to do kind of these magic tricks where you make things disappear, and it's totally allowed. So moving to another example with the GCF. So the format is we're doing 2 examples of each of these types. So here, everything is divisible by 2. So 0 divided by 2 is 0. This divided by 2 is just x squared. Divide by 2 again, and divide by 2 again. And now we're in that same BC situation, looking for two numbers that add to -2 and multiply to -48. So it would be x minus 8 and x plus 6. If you set each of those equal to 0 and solve, you'll get x equals 8 and x equals -6. Sound good?
Very good.
Alrighty. So now the next sort of big thing to be aware of is if BC factoring doesn't work, like it doesn't work in this situation that we have on the screen here, we have two choices. We have completing the square and the quadratic formula. Now, in my book, they're both equal in priority, and there are different situations where one might be favorable over the other, but generally they're of even priority in terms of which one I'd want to choose. My own bias would say always lean toward completing the square whenever possible because it's less work, but it's kind of a matter of debate there. But we're going to talk about the quadratic formula first, and you'll see why in 1 second. So the quadratic formula is x is negative b plus or minus square root of b squared minus 4ac all over 2a. So if that looks complicated, you're right, which is one of the reasons why I recommend completing the square more often. So with this quadratic, the a is in front of the x squared, the b is in front of the x, and the c is the last number off to the end. So we're just going to plug that into here. So -8 plus or minus square root of 8 squared minus, 8 squared minus 4 times 1 times 2 all over 2 times a. And then you just go through simplifying. 64 minus 8 is going to be 56 all over 2. And this could be simplified in radical form, but it's going to be ugly no matter what you do. So -8 plus or minus, and 8 is really 2 root 2. So let's see. This thing right here is really the same as 4 times 56 divided by 4 here. 4 times 14. So this is the same as 2 root 14 all over 2. And you can divide each of the three pieces by 2. So -4 plus or minus root 14 all over 2. And as ugly as that is, that's the right answer. So on certain questions, we'd see that as one of the answer choices for this situation. Any questions, Patrick?
You're going to need to memorize this formula if you don't already know it, if you choose to use it. That's the first thing I would say. And then the second thing also, just to note, obviously the BC factoring form for this one, x squared plus 8x plus 2, there's no combination of numbers that would work. So just for students to see, that's indeed why we have to utilize this more complicated formula.
Yep, definitely. Mm-hmm. So yeah, if BC factoring doesn't work, then these are your second choice. And I've got another example where we're doing the same thing. So in the interest of time, I might skip that one, but just show that there's a GCF. So we're always on the lookout for a GCF. And even though it looks like there are no two numbers that add to -10 and multiply to -9. So then you would say A is 1, B is -10, C is -9, and plug into the quadratic formula just like we did on the previous question, which we'll skip here in the interest of time. But now the quadratic formula leaves us open to something pretty unique that they talk about in Algebra 1. So here's the quadratic formula again. And when you put something into the quadratic formula, now I'm going to give you fake numbers. There are 3 ways that this could all work out. I could have like 2 plus or minus square root of 4 over 3, 2 plus or minus square root of 0 over 3, 2 plus or minus square root of -4 over 3. So these are not the same numbers we're seeing on the left, but just giving you the idea of what we're going to be doing. Depending on what value you have right here, that'll dictate the number of solutions. Because in this situation here, I'd be adding 2 and taking away 2. So I'd have 2 answers. In the middle one, I've got a 0 under the radical. So I'm not adding or taking away anything. So that's just 1 answer. And then here I've got a negative under a radical, which is not allowed in the world of math. So negative under a radical or a 0 in a denominator are the only 2 things not allowed in math. So we have the famous no solutions, which I'm calling 0 answers here. So all we did is we varied the value of what we have for our b squared minus 4ac. as opposed to the entire quadratic formula, just a tiny little piece of it. And depending on what you get for that number, it dictates how many answers you have. So the quadratic, if you see how many solutions, then that's what you should be leaning toward, is figuring out how can you work out this thing, which is called the discriminant. Any questions, Patrick?
No, just to hammer home the point, if it's positive, two answers, it's equal to 0, 1 answer, and if it's negative, 0 answers, just to sum up.
Yep,
Well
so when you're dealing with the discriminant, if the discriminant is positive, 2 answers, if it's 0, 1 answer, if it's negative, 0 answers. So in this situation, we're given a system of equations, we're asked how many solutions. So by the way, that's an intersection. And the way we teach intersection is whenever possible for the SAT, you want to get both equations in a y equals format and set those equal. Just history just seems to show that that's the easiest way for most situations. If that's not possible, then yeah, you can substitute or do something else. But 9 times out of 10, you're able to do this. So what I mean by this here is we're going to solve for y in the top equation. So take away 4 from both sides, divide by 2. So you get y equals x minus 4 over 2. So the first one's already in a y equals format. And now we've gotten the second one in a y equals format. So the rule in purple there says, get them both in that y equals format and then set those equal to each other. So now we're going to do x minus 4 over 2 equals 2x squared plus 8x plus 5. And this just looks like a handful, but keep in mind we have something a little easier here because we're not looking for the actual solution. We're looking for just how many solutions, the number of solutions. So just to simplify this out a little, we're going to multiply by 2 to get rid of the denominator on the left. So x minus 4 equals 4x squared plus 16x plus 10. Then we're going to realize that this is a quadratic situation. So before we do anything else, we need 0 on one side. So minus x and plus 4. And so we'll have 0 equals 4x squared plus 15x plus 14. And now we're going to deal with the how many solutions. So we need b squared minus 4ac. And we're going to judge whether that answer is positive, negative, or 0. So 15 squared minus 4 times a, which is 4, times c, which is 14. So 225 minus 4 times 4 times 14, whatever that is. So 224. And the answer ends up being 1 for the discriminant. Now, how tempting would it be to go ahead and say that there's one possible answer here because we just got a 1. But if the discriminant is positive, that's this situation right here where there are 2 answers. So how many solutions to this situation? 2. With better handwriting than that. 2 right there. All right, so that's the idea of using the discriminant to find the number of solutions. It would be tougher in this already tough question to find the actual solutions and then count them. So the advantage on the SAT goes to those who can kind of take the shortest, most efficient way in every possible situation. And usually that's the textbook way, surprisingly enough. Patrick?
One question for you, yeah. One question would be for any students out there. Are there any other ways of figuring this out aside from the method we just utilized?
Well, one answer that comes to mind in response to that question is that I believe that every student should be showing up to the SAT with a graphing calculator. It's allowed on the calculator section, and it's an unfair advantage. But it's not an unfair advantage because it's allowed. So what happens is, if you're the one person that's using a scientific calculator or even less than that, then you're just at a disadvantage. So on the SAT, definitely big time, the advantage goes to the calculator nerds. So if I were maybe puzzled and I didn't know the actual way to do this, and I have a TI-84 Texas Instrument calculator right in front of me on the SAT, I could just graph both of these equations and look and see how many times they intersect. So, you know, definitely always use that calculator. If you don't have one, maybe go on Amazon and get one used or something. But it's non-negotiable. To do your best on the SAT, you need a graphing calculator, and you could have used it here. So okay, well, we've got so much more to say on this, and we are starting our daily math and verbal SAT podcast. So spread the word at your school, let people know about this amazing free resource, and if we get some positive feedback, it'll help us confirm that this is a good thing that is helping a lot of people. and is brought to you by Aspire Test Prep, SAT and ACT tutoring. You can find us on YouTube, you can find us on Facebook, and you can get my information, my contact information, or Patrick's information from those pages as well. Anything to add, Patrick?
And then also just keep an eye out for the YouTube channel. If you want to subscribe, we will be uploading some snippets from the first 2 live streams that we had. They are being uploaded at the moment, where we discussed exponentials, the complex conjugate, a bunch of other math topics, a lot of verbal topics, and reading questions, I believe, as well. And then there will also be some videos geared more towards your parents. Just keep an eye out on the Aspire Test Prep YouTube channel. We'll be uploading videos all week, and we'll be doing this on a daily basis also. So make sure you're tuned in each day.
Sounds good. And this exact lesson will be continued tomorrow, where we'll talk about other aspects such as completing the square, more discriminant, GCF factoring, differences of squares, all the different applications of quadratic factoring that you must know in order to do your best on the SAT. So thanks, guys, and have a wonderful day.